August 1943, occupied France. The American fighter did not burn on impact. That alone surprised the German recovery team. The P-47 Thunderbolt had come down hard in a wheat field after taking flak damage over northern France. The landing gear had collapsed. One wing was scarred. Hydraulic fluid leaked into the soil, but the fuselage remained intact. The cockpit was undistorted. The engine block had not cracked. For the Luftwaffe, this was an intelligence windfall. The aircraft was quickly secured, disassembled where possible, and transported under guard to a technical evaluation site. The engineer assigned to the inspection was a specialist in power plants and high-altitude performance. His task was routine: identify design flaws, production shortcuts, weaknesses German pilots could exploit. He began with the engine. The Pratt & Whitney R2800 Double Wasp was larger than expected. An 18-cylinder, air-cooled radial producing over 2,000 horsepower in operational configuration. German factories struggled to maintain tolerances on engines producing far less power. Here, crankshaft alignment, cylinder machining, and bearing surfaces showed consistency across components. Not hand-fitted craftsmanship, but repeatable precision. That distinction mattered. German engines relied on skilled labor compensating for limited tooling. American engines relied on tooling so precise that skill variability barely mattered. The engineer noted this immediately. It meant scalability. Then he examined the turbo-supercharger system. Unlike German designs, which placed experimental turbo units externally or relied on mechanically driven superchargers, the P-47 integrated a General Electric turbo system deep inside the fuselage. Exhaust gases were routed through reinforced ducting to drive the turbine, maintaining manifold pressure at altitudes above 30,000 feet. Germany had tested similar systems. None were reliable in mass production. Heat management alone defeated most prototypes. Yet here was a combat aircraft using the system operationally, not in small numbers, but as standard equipment. The engineer measured the duct thickness, the heat shielding, the access panels designed for rapid maintenance. This was not a laboratory aircraft. It was built for careless handling by overworked ground crews, and still functioned. Next came the airframe. The P-47 was absurdly heavy for a fighter, nearly 5 tons loaded. German doctrine favored light, agile interceptors. This aircraft ignored doctrine entirely. Thick-wing spars, redundant control cables, armor plating around the cockpit, an engine that added weight but absorbed punishment. Self-sealing fuel tanks showed evidence of previous damage, patched, resealed, flown again. The engineer understood what this meant in practice. A German Bf-109 hit once was often lost. A P-47 hit once was often repaired. He turned to production data. Captured intelligence summaries confirmed American output. By mid-1943, the United States was producing over 500 P-47s per month. Engine production targets for the R2800 exceeded 125,000 units across multiple factories. Germany could not disperse production at that scale. Bombing disrupted supply chains. Skilled labor was irreplaceable. Each loss compounded the next. The engineer wrote numbers in the margin of his report. Replacement rates, loss ratios, training pipelines. The conclusion formed quietly without emotion. Germany was not losing because of inferior pilots. Germany was not losing because of tactical mistakes. Germany was losing because it could not replace losses faster than they occurred. This was not a battle problem, it was a mathematical one. The engineer submitted his report using cautious language. No predictions, no political statements, just measurements, comparisons, production estimates. He never received a reply. In the Reich, such reports were often labeled pessimistic, or quietly ignored, or classified into silence. Admitting the truth meant admitting inevitability, and inevitability was unacceptable. But inevitability did not require permission. As P-47s filled the skies over Europe, absorbing damage, escorting bombers deeper into Germany, and returning again and again, the engineers' calculations proved accurate. The war was being decided far from the front line, inside factories, inside assembly lines, inside numbers that could not be argued with. Some men saw that reality early. They were not generals, they were engineers. By late 1943, the consequences of American production were no longer theoretical. They were appearing in Luftwaffe combat reports. German fighter units began reporting a pattern that defied pre-war assumptions. P-47 formations did not disengage after taking losses. They did not scatter when attacked aggressively. Instead, they absorbed damage, dropped altitude, regrouped, and returned the next day. Sometimes the same aircraft returned. Pilots noted serial numbers, distinctive repair patches, bent control surfaces that had clearly been straightened and flown again. This should not have been possible. The BF-109 and FW-190 had been designed around performance margins. Light structures, high climb rates, precision-engineered components that delivered superiority, but only as long as tolerances held. Once stressed, damaged, or roughly maintained, performance degraded rapidly. American doctrine assumed the opposite. The P-47 was designed to be mistreated. Combat damage reports from the 8th Air Force showed aircraft returning with cylinders shot out, control cables severed but backed up by redundancies, turbo-supercharger systems scarred by shrapnel yet still functioning. Ground crews replaced entire modules rather than rebuilding components piece by piece. This shocked German maintenance officers. German repair philosophy depended on skilled craftsmen restoring damaged aircraft over days or weeks. American logistics replaced sections overnight. Entire engines were swapped in hours. Aircraft that should have been written off were back in service within days. The problem intensified when escort missions expanded. In early 1943, American bombers often flew beyond fighter cover. Losses were catastrophic. By late 1943, P-47 groups were escorting bombers deep into the Reich, engaging interceptors repeatedly, then diving away at speeds German fighters could not match. The Thunderbolt was not elegant, but above 25,000 feet it was fast. In a dive it was untouchable. German pilots learned quickly, if a P-47 disengaged downward, pursuit meant death. Structural limits on German airframes made sustained high-speed dives lethal. Wings failed. Control surfaces locked. This altered combat behavior. Luftwaffe pilots began avoiding prolonged engagements. Intercepts became cautious. Aggression, once the Luftwaffe's defining advantage, was slowly eroded by attrition mathematics. Losses were no longer balanced. A German fighter pilot represented years of training, thousands of flight hours, irreplaceable experience. An American pilot, while well-trained, was part of a system built to absorb loss. Training pipelines in the United States produced replacements faster than squadrons could lose them. By mid-1944, internal Luftwaffe memoranda admitted the imbalance. One report noted that American units could lose an entire group and replace both aircraft and pilots within weeks. German units losing veteran pilots never recovered operational effectiveness. Equipment losses were even worse. German aircraft production increased on paper, but bombing disrupted engines, bearings, fuel systems, and transportation. American factories, untouched, improved output and quality simultaneously. Later, P-47 models arrived heavier, stronger, faster, not weaker. The engineer who had examined the captured Thunderbolt saw his conclusions play out across the sky. This was no longer about design superiority. It was about sustainability. Every mission the Americans flew forced Germany to choose: commit dwindling experienced pilots or concede airspace. Each choice led to the same outcome: attrition without replacement. By the end of 1944, German pilots openly acknowledged that victories no longer mattered. Shooting down 5 bombers meant nothing if 50 replaced them the next week, escorted by fighters that could not be worn down. The war in the air had transformed, not into a contest of skill, but into a contest of endurance, one Germany had already lost. And still, the truth could not be spoken openly, because admitting the real cause of defeat meant admitting that courage, sacrifice, and brilliance were irrelevant against factories running 3 shifts a day, untouched by bombs. In the Reich, that was not analysis. That was heresy. By early 1945, the reality of industrial warfare could no longer be ignored, even in the Reich. Former Luftwaffe officers and engineers, once bound by ideology and fear, began to acknowledge privately what the captured Thunderbolt had already revealed 2 years earlier. The numbers did not lie. Germany's production capacity was insufficient. Training pipelines were collapsing. Experienced pilots were irreplaceable. American forces could replace losses faster than Germany could inflict them. Every tactical victory, no matter how brilliant, was temporary. Every daring sortie, every tactical innovation, was ultimately neutralized by a simple mathematical fact. The Allies could outproduce, out-repair, and out-sustain the German war effort. One German engineer recalled that day in August 1943 when the P-47 landed. He had touched the airframe, inspected the R2800 engine, and realized that German factories could not replicate tolerances that high. Every component screamed a truth he could not speak. Defeat was inevitable. But for months the regime demanded silence. Reports that hinted at systemic disadvantage were labeled defeatist and destroyed. Intelligence officers who dared report production gaps risked arrest. By 1944, evidence was unavoidable. American bomber formations could fly at unprecedented altitudes, escorted by Thunderbolts that shrugged off damage that would cripple any Luftwaffe plane. German pilots, increasingly inexperienced, were being funneled into death traps, their skill wasted against the relentless tide of replacements. Even elite German units, like JG-26 and JG-54, were reduced to piecemeal efforts, a few aces against waves of industrially produced aircraft and pilots. Operational reports captured the despair. Memo after memo admitted the uncomfortable truth. The war was no longer being fought in the air, but in factories, logistics hubs, and assembly lines. Aircraft production numbers, spare parts inventories, and pilot training rates dictated the pace of the conflict more than courage or tactics. After the war, German generals and engineers were brutally honest. General Adolf Galland, former Luftwaffe fighter ace, noted that by late 1944 they understood they were outnumbered and outbuilt. Another engineer recalled that by 1944 the Reich had lost the war on paper long before it was lost in the sky. Even the famed Messerschmitt factories, once the pride of German engineering, were unable to compete with American scale and redundancy. The captured P-47 became a symbol of this reality. Its landing had been a minor event, almost accidental. Yet it encapsulated a systemic failure. German skill and valor could not overcome American industrial might. Every bolt, every rivet, every module told the same story. Germany was fighting a war it could not win. Historians now see the event as a microcosm of the conflict. The war was decided long before Normandy. It was decided the moment American factories began producing planes, tanks, and engines at a scale Germany could never match. Technology mattered, but production capacity mattered more. Doctrine mattered, but sustainability mattered more. Strategy mattered, but logistics mattered most. For the men in that Reich factory, truth was terrifying. To see it clearly was to face the inevitability of collapse. And yet obedience, ideology, and fear of reporting bad news kept them building, repairing, and fighting until the world finally caught up with reality. By the end, Germany's defeat was not a mystery of courage, tactics, or leadership. It was a mathematical certainty, evident to anyone willing to read the numbers. The P-47 Thunderbolt was not just a plane. It was a messenger, and Germany, tragically, could not listen.